Welcome to the Center of Mass Talk. We are going to go over a skill that's needed for problem number 2 in the challenge problems, but just a general know-how on the AP exam. We need to try and figure out an object's center of mass. And for point masses, it's pretty straightforward. It should make some sense if I handed you this baton. Let's just say the baton is massless. And there was a 3 kilogram mass on the left side, 2 kilogram mass on the right side. You could tell me, Mr. Meyer, I think the center of mass should be somewhere over there. It's not exactly going to be at the midpoint because there's more mass over here. And I would say, that's right, but could we figure out exactly where this position is? Say from the 3 kilogram mass, and you could say, maybe with some mathematics. So let's dive in. Where is this baton's center of mass? Well, we are going to, one, define an origin, which we're free to do. It would be more helpful, at least for algebra's sake, to define an origin on a mass. So I'll define my origin to be right there. I'm going to add up all the mass distances, which is just each mass m times r, how far it is from the origin, and then I'm going to average over the total mass. So check this out. X, center of mass, cm, I'm going to use that notation to define this distance from the origin to the center of mass. So here I go. I start with my first mass, 3 times 0 because it's on the origin, plus 2 kg times the 5 meter. Oh man, that is a huge baton, 5 meters. And I divide it all over my total mass. Well, 3 plus 2 is 5. And I get the expression 10 over 5, kilogram meter over kilogram. The kilograms cancel out. And as I expect, I should get a unit of meter. So the center of mass for this baton would be 2 meters from the 3 kilogram side, which, as we guessed, it would not be at the midpoint. So that's for point masses. It's relatively straightforward if we look at a continuous mass, say, of the bar that actually has some weight to it. So let's say this bar has 10 kilograms of mass. We're going to assume uniform density. What does that mean? It's saying that at every section of this bar, we would expect to see the same mass in each section if I divide my sections up evenly. There's not one side with more concentrated mass than another side. If I just gave you the bar, you could say if there's uniform mass density, then the center of mass should be at this point here. And that is at 1.5 meters from one of the ends. Now I take, let's say, something sticky. I was going to say gum, but gum isn't 1 kilogram. Oh, maybe you are chewing a 1 kilogram mass of gum and you stick it over there and you hand me this bar and you say, find the center of mass. So we now have this mass at the center from the entire bar plus the 1 kilogram thing of gum that sticks to the end. So to find the new center of mass, we start with the origin. Let's call it, I don't know, right here. So the first bit here, notice that the 10 kilogram bar is multiplied by 1.5 because that's the center of mass of just the bar, plus the 1 kilogram bit of gum times how far it is away from the origin, all divided by the total mass of the system, 10 kilograms plus the 1 kilogram gum, gives me this expression. And I put that into a calculator and I get 1.64, which means that the center of mass is something like this distance right here. This is not the scale. What a shame. So that distance from here to here, that is 1.64 meters. The equation that you could put down in your notes so that you could figure out the center of mass looks something like this. The summation of all the mass distances over the total mass. Put another way, that's just adding up each mass times distance from the origin, and then dividing that by the total mass. This dot 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 means as many pieces as you have. And if you've taken calculus, you would know that if we see this, we would start to take the integral just to make life simpler. This scale comes into practice when we have this rod situation in problem 2. The ball sticks to the rod, and then it comes up to this new height. And you're going to want to use mgh equals 1/2 I omega squared, because it's all going into rotating this body. And you're going to be tempted to say, I know this height, and I know this. Well, that must be h. But it's not. It's really the center of mass. So x, center of mass, to this x, center of mass, because the center of mass won't change as the bar swings around. Make that more appropriate. So it's this distance then, from here to here, that's going to be your h in that energy analysis. Okay, until next time, see ya.